Welcome to Agent Memory and Verifiable Self-Evolution. This is a 13-episode series about a question that has become urgent faster than the field has been able to answer it. If an agent is going to improve itself, what exactly does it improve, where does that improvement lie, and how would anyone know it was an improvement at all? Episode 1 sets up the problem. Let us begin. The series runs along 6 stages. Store asks what is worth keeping at all. Organize asks what structure makes recall cheap and correct. Control treats writing, evicting and consolidating as decisions rather than defaults. Evolve is where the agent starts changing its own prompts, its own workflows, and eventually its own code. Verify is where we ask the question the rest of the field tends to skip. And govern is where we ask who is accountable for an agent that is no longer the artifact you shipped. 13 episodes sit on this spine. You will see this strip at the foot of every slide with the current stage lit, because the most common way to get lost in this literature is to forget which of these 6 questions a paper is actually answering. By the end of this episode you should be able to do 3 things. First, separate 4 ideas that get used interchangeably and are not interchangeable: the context window, retrieval, memory, and learning. Second, state the self-evolution thesis, the claim that long-term memory is the substrate improvement accumulates in, and say what work that claim is doing. Third, name the 3 ways a self-improving loop rots, because the back half of this series is built specifically to prevent them. If you leave with only the third, that is still a good outcome. Here is the failure that motivates everything. We will use one toy agent throughout the series, a claims triage assistant, running entirely on synthetic data, that decides whether an insurance claim can be settled automatically or needs a human. On Monday it is asked whether a particular class of claim falls under an excess waiver. It answers correctly and it explains itself well. On Friday it is asked the same thing and answers wrongly, with equal fluency. Nothing about the model changed. No weights were updated. No prompt was edited. What changed was the state it was carrying: something was written, something was retrieved, and something was not invalidated. That is a memory bug, and it will not show up in any single-turn evaluation you run. Start with the standard loop. The agent observes, it reasons about what to do, it acts, and it observes the result. Interleaving reasoning traces with actions this way is what made language model agents practical, and it is the skeleton underneath nearly everything in this series. Now watch what is missing. Between the last action of one episode and the first observation of the next, there is nothing. The loop has no place to put what it learned. In the original formulation that is perfectly fine, because the task is assumed to fit inside one episode. The moment the task spans sessions, a customer you have spoken to before, a policy you looked up last month, that dashed box has to become real. Everything else in this series follows from filling it in. A common first answer is, give it tools. Teach the model to call an API, a calculator, a search engine, and it can go and find what it needs. That is genuinely powerful, and self-supervised tool learning showed that the model can decide for itself when a call is worth making. But notice carefully what tools give you. They extend the set of actions available in the present. They do not give the agent a past. A retrieval tool over a static corpus does not remember your conversation, it queries somebody else's documents. Adding tools to a stateless loop gives you a very capable agent with amnesia. The second common answer is, use a longer context. Here we need to be precise, because this is where most of the confusion in the field lies. For contrasts. Capacity, a context window is bounded and the bound is architectural, whereas a memory store is bounded by disk. Persistence, the window is discarded at the end of the session, the store outlives it. Addressability, everything in the window is present at once and competing for attention, whereas a store is queried, so you decide what enters. And marginal cost, adding to the window costs tokens on every single subsequent turn, whereas adding to a store costs once to write and only costs again when it is actually retrieved. Long context and memory are not the same tool. At long horizons they are not even substitutes. That last contrast deserves a picture, and I want to be careful about what this picture is. These curves are schematic. They illustrate a shape, not a measured benchmark, and the slide says so. As the interaction horizon grows, stuffing everything into context grows superlinearly in cost, because you pay for the whole history on every turn. Naive retrieval flattens the cost but degrades in accuracy as the store fills with near duplicates and superseded facts. Curated memory, where something actually decides what to keep, merge and discard, has a higher fixed cost and a much flatter slope. Let me put a number on that, using our claims agent. Suppose each session leaves about 4,000 tokens of history worth keeping, and one caseworker comes back 200 times over a year. Carrying all of it in context means rereading 800,000 tokens on every single turn, forever, whether or not the current question touches any of it. Retrieval reads a few thousand instead, but now you are betting that the retriever picked the right few thousand out of 200 sessions of near duplicates. Curated memory pays a third kind of cost, a distillation pass per session, to make that bet easier to win. Which of the three is cheapest depends entirely on how often the history is actually needed. The crossover point is the engineering question, and where it sits for your workload determines whether the rest of this series is worth your time. So here is the definition we will use for the next 13 episodes. Agent memory is persistent, addressable, updatable state that changes future behavior. Every word carries weight. Persistent, it survives the session. Addressable, you can retrieve a specific item, which rules out saying it is in the weight somewhere. Updatable, you can revise it, which rules out an append-only log you never correct. And changes future behavior. If writing it makes no difference to any later decision, then you have built a logging system, not a memory. That last clause is the one most systems quietly fail, and in the lab at the end of this episode 1 I'm going to ask you to measure exactly that. Memory is not one thing. Working memory is what the agent is holding right now, the current claim, the current turn. Episodic memory is what happened. This customer called in March and was unhappy. Semantic memory is what is true. This policy class carries a $500 excess. Procedural memory is how to do something, the escalation sequence when a claim exceeds a threshold. Our one small agent needs all four, and they have different write patterns, different lifetimes, and different failure modes. Hold on to the fact that in most deployed systems a single vector store is being asked to play all four roles at once. And plant one caveat now, because it is more interesting than it first looks. This four-way split is textbook cognitive psychology, and it is not the taxonomy that either of the two most recent memory surveys actually uses. One replaces it with forms, functions and dynamics. The other replaces it with two axes, whether the memory is procedural experience or conceptual knowledge, and whether it persists within one trajectory or across many. Two independent surveys, both walking away from the classic split, in two different directions. Episode 2 is largely about why. Now the claim that gives this series its subject. The argument, made most directly in the long-term memory literature, is that self-evolution is not primarily a training problem but a memory problem. Without persistent, revisable state, improvement has nowhere to accumulate. Note the form of that argument. It is not a theorem and it is not an empirical result. It is a reframing, and its value lies in what it makes visible, namely that a great deal of what we call learning in agentic systems is actually the work of writing things down well. I am going to treat that reframing as productive, and then spend most of the series pressing on the part it leaves open, which is whether what got written down was true. Is any of this measured, or am I telling you a story? It is measured, and by four different groups. First, magnitude. The long MEM-eval benchmark reports that commercial chat assistants and long-context models lose roughly 30% of their accuracy on remembering information across sustained interactions. Second, structure. That is not one failure. The benchmark separates 5 distinct abilities, including the one systems almost never have, which is abstaining when they do not know. Third, transfer. A more recent agentic benchmark finds that agents which are nearly saturated on a popular long conversation benchmark perform poorly once memory has to guide action across interdependent sessions. And fourth, the finding I want you to carry into the rest of the series. On one widely used benchmark, temporal reasoning F1 measured just under 3%, rising to about 17% once explicit state labels were added. 3%. That number was sitting inside an aggregate score that looked broadly acceptable. This is the whole argument for decomposed evaluation in one figure. If memory is the substrate, evolution is the process. The useful first move is to stop asking whether an agent self-improves and ask two sharper questions instead, and I am borrowing both from a recent systems-oriented survey. Its framing is worth adopting wholesale. A modern agent is a foundation model coupled to an operational scaffold of prompts, memory, tools and control logic, and self-improvement is a self-induced update operator that obtains and commits updates to either the parameters or the scaffold. So, question 1, what is the update target? 6 candidates, from the prompt through to the harness. Question 2, what signal drives the update? Human correction, execution outcome, self-critique, or a learned reward. That grid is where almost every method you have heard of lives, and the empty cells are as interesting as the full ones. A third dimension, whether one agent or a population does the updating, we defer to Episode 8. Episode 6 works through the grid systematically. Zoom in on the agent changes itself column and you get a loop with 4 stages. Act in the world. Record what happened. Distill the record into something reusable, a rule, a note, a skill, a revised prompt. Update the agent with it. Then act again, now conditioned on what you wrote. This loop is the engine of everything in the second half of the series. It is also, and this is the important part, the very same loop that produces every pathology we will spend 3 episodes defending against. There is no separate failure mechanism to isolate. The gains and the rot come from the identical structure, which is why you cannot secure the gain simply by having good intentions. 3 specific failures. First, self-confirmation. The agent grades its own experience using the same model that generated it, so its errors become its training signal, and its confidence rises while its accuracy falls. That is Episode 9. Second, and here I will use a sharper term than staleness, ghost memory. Old values, current values, and the record of the change all coexist in the store, they stay mixed together during retrieval, and they arrive at the answer model with nothing marking which one is live. Deleting the old value loses the history, keeping it unlabeled corrupts the answer. That is Episode 5. Third, poisoning. Content enters through one of a small number of right channels and changes behavior weeks later, long after any inspection would have run. That is Episodes 10 and 11. Notice that none of these are model failures. All 3 are memory failures, and all 3 are invisible to single-turn evaluation. Which brings me to the standard this series is going to hold things to. When a paper or a colleague tells you a system improved itself, 3 things have to be on the table before that sentence means anything. A proof obligation, what specifically is being claimed, higher accuracy, fewer escalations, better retention at session 50. An instrument, what measured it, and could that instrument have been gamed by the very thing it was measuring? And a cost, what did the improvement consume in tokens, in storage, and in human review time? Improvement claims without all 3 are not wrong. They are simply not yet claims. Most of the genuinely interesting work in this field lives in the second item. For the instrument question I am going to use a framework from my own work, and I want to flag clearly that this is mine rather than a consensus position, so you can weigh it accordingly. For checks, for questions, applied to any piece of memory. Correct, is it grounded in an execution or a citable source, or did a model simply assert it? Consistent, does it contradict something already in the store? Current, is it still true, and do we know when it stops being true? Complete, are the fields we need in order to use it safely actually present? 4 gates. A write passes all 4, or it is flagged, or it is quarantined. The animation shows one write failing the third gate. The 4 checks become far more useful when crossed with the 6 memory operations we meet in episode 2. Write, index, retrieve, update, forget and consolidate, against correct, consistent, current and complete. 24 cells, and what you get is a risk map. The dominant risk on write is ungrounded assertion. On update it is silent contradiction. On forget it is losing the only record of a validity boundary. And on consolidate, which is the cell that surprises people, the risk is manufacturing a claim that no source ever made. Here is that one concretely, from our claims agent. 2 notes exist. Note 1, written in March, this policy class carries a $500 excess. Note 2, written in June, the excess was waived for flood claims. A consolidation pass merges them into one tidy sentence, that this policy class carries a $500 excess, waived for flood. Neither source said the waiver still stood under March terms. The merged item is shorter, more confident, more retrievable, and wrong. And because it replaced both parents, the evidence you would need to catch it is gone. We come back to this matrix in episodes 5, 9, and 11. It is the closest thing this series has to a checklist. If you want 6 things you can actually go and implement, here they are. Provenance, every item records where it came from and through which channel. Validity interval, every item records when it becomes true and when it stops being true. Idempotent write, writing the same thing twice does not produce 2 items that can later disagree with each other. Reversibility, every write can be undone, and the undo is itself logged. Conflict policy, when 2 items disagree, something decided in advance which one wins. And a staleness budget, a stated maximum age per class of memory, with an audit that actually checks it. None of these are research problems. All 6 are routinely absent from systems running in production today. 6 regions, so you can choose rather than read all of them. If you want the argument rather than a catalog, the long-term memory paper is where the thesis lives. If you want vocabulary, the Forms Functions Dynamic Survey is the most careful, and it does something the others do not, which is draw a hard line between agent memory and its neighbors, retrieval augmented generation and context engineering. For cognitive grounding, the Neuroscience 2 Agent Survey starts from the fact that the model is natively stateless and asks what human memory suggests you build on top. For self-evolution taxonomies, there are the What When How Where and the Lifelong Systems surveys. And for a systems view, the self-improvement survey I mentioned earlier, agent as model plus scaffold, organized by update target and driving signal. And the 6th region I want to dwell on, because it partly preempts me. A survey of 1,250 papers on recursive self-improvement does the thing I was about to claim nobody does. It takes the question of what a claimed improvement must satisfy and turns it into a hierarchy, ordering improvement signals from formal verifiers at the strong end down to a model's intrinsic self-assessment at the weak end, and observing that demonstrated self-improvement strength tracks that ordering. If you take one reference away from this episode, take that one. So the gap is not that nobody asks how you know. The gap, and this is that survey's own conclusion rather than mine, is that governance-grade measurement of self-improvement remains the emptiest niche in the field. That is where this series aims, and episodes 12 and 13 are where it lands. 5 suites, positioned by what they actually put a number on. The first works over freely scalable chat history and is still the only one I know of that scores abstention. The second moves into web environments, with histories running to 500 trajectories and 115 million tokens, and it scores things a chat benchmark cannot: workflow knowledge, environment gotchas, whether the agent notices a false premise. The third organizes everything along 2 axes, whether memory is used inside one episode or across episodes, and whether the content is knowledge or execution experience. The fourth is the agentic one, where memory has to guide action across interdependent sessions rather than just answer questions about the past. The fifth is a security benchmark, which does not belong on a capability axis at all but does belong on this slide. And the sixth builds its task set straight out of memory science, scoring 4 competencies: accurate retrieval, test-time learning, long-range understanding, and selective forgetting. Its headline finding is the one to remember: no method it tested mastered all 4. 2 honest gaps remain. Abstention is scored by essentially one sweet, and deliberate forgetting by essentially one other, so the 2 capabilities that require a system to give something up are the 2 we measure worst. And the running cost of memory is scored by almost none, because end-to-end task metrics treat the memory system as a black box, which is a point made directly by a recent data management study of 12 such systems. Some practical matters. Every episode has slides, a narration script and a lab in the repository, all under a permissive license. References are numbered R01 through R55 consistently across all 13 episodes, so a citation on screen in episode 11 means the same paper it meant in episode 1. Every diagram in this series is original, where a diagram re-expresses information from a paper it says schematic after, followed by the reference number, and where it replots reported numbers it says so. And there is a corrections file. This is a fast-moving literature and some of what I say will age badly. When it does, the correction goes in the repository rather than quietly nowhere. Now the lab. Take whatever agent you already have and instrument its memory writes. For every write, log 4 things: the source, the timestamp, the validity interval if one is knowable at all, and a hash of the content. Then run your normal workload for a week and answer a single question. What fraction of everything you wrote was ever read back? In every system I have done this on, the answer has been uncomfortable. Most of what gets written is never retrieved, which means most of the write cost is buying nothing, while still adding to the surface area that can go stale or be poisoned. 30 lines of logging. It reliably changes how people design everything after it. 5 things to take away. The context window is not memory, and longer context does not make the problem go away. Memory is persistent, addressable, updatable state that changes future behavior, and that last clause is a test most systems fail. Self-evolution is substantially a memory problem, not only a training problem. The loop that produces improvement is the same loop that produces self-confirmation, staleness and poisoning. And an improvement claim needs a proof obligation, an instrument and a cost. Next episode, the anatomy of agent memory. 4 forms, 5 functions, 6 operations, and the point at which the brain analogy stops being useful. See you there.